Hi, welcome to my channel Cloud with Girish. In my previous videos, I covered various use cases for AWS serverless Lambda functions, ranging from a simple hello world example to more advanced scenario involving API gateway, DynamoDB, and integration with Amazon Bedrock for generative AI applications. I also shared a video demonstrating how to create a Lambda layer using the AWS Management Console and reference it for the Lambda function using AWS SAM. If you are interested in these topics, please visit my channel or check the links provided in the description for detailed walkthrough. In this video, I will show you how to work with Lambda layers using AWS SAM, an infrastructure as code framework for building, testing, and deploying Lambda functions to the AWS Cloud. This will include creating a Lambda layer using AWS SAM and configuring a Lambda function to reference the layer. There are several ways to create Lambda functions using the IAC approach, including AWS SAM, CloudFormation, and Terraform. While I typically use AWS SAM, I may share a few examples using Terraform in the future. Let's look at the architecture. In this architecture diagram, you will see that there are two Lambda functions here, and if I have the Lambda function code plus the common function, both the code are together, and that means my deployment package size will be bigger. And then if I have a common function which is used by both the function, I need to embed that code in both the function when I'm deploying the Lambda function. If I'm using the layer, I can separate the common function into this layer, and then this layer can be referenced by each of the Lambda function that need to use that common function. And that's really one of the key benefits of using the layer. So your deployment size for the Lambda function is smaller, and then you have the reusability by separating out the common function in a layer. Let's look at the prerequisite. Familiarity with the AWS Management Console, a basic understanding of AWS SAM, a basic understanding of Lambda function, a basic understanding of library and reusable component functions, and a basic knowledge of Python programming. Let's get started. We will look at the intro to Lambda layer. We'll look at what are Lambda layers, some of the benefit and constraint of Lambda layers, and few use cases. I will also review the AWS SAM template YAML file. This file contains the SAM code to create the layer and then reference the layer in the function. Since we are using AWS SAM for the entire solution, I will build and validate the Lambda function using AWS SAM, and then at the end we'll deploy the function using AWS SAM. Once we're done with the setup and we have validated it, then I'll do some cleanup, which include deleting the Lambda function and the layer. So let's first review what a Lambda layer is. A Lambda layer is a way to share reusable code and libraries among multiple Lambda functions. It makes the size of Lambda function deployment smaller. Also, by packaging shared functions in a Lambda layer, you can simplify the deployment process and ensure consistency across functions. In order to create the layer, first step is to create a zip file that contains your sharing function code or supplement library. Once created and uploaded in the AWS using console or infrastructure as code, this layer then can be referenced by the Lambda function. Lambda layer offers several advantages, including reusability of code. For example, a common function can be shared across multiple Lambda functions. Simplified deployment. So by placing the common code in a layer, the deployment size of Lambda function is reduced. This also provides a central location for updating shared code. Inline function editing, if you are interested in that, basically updating the Lambda function through the Lambda console, through the management console. So with reduced deployment size due to layers, Lambda function can be edited inline in the AWS Management Console without exceeding size constraint. I think currently the size constraint is 3 MB. So if your Lambda code function deployment code is like bigger than 3 MB, then it basically need to be in a compressed form. That means you can do the inline function editing. And then library management. So frequently used library can be packaged in a layer, making them accessible to multiple functions. Now, when there are benefits, there are some constraints also. So keep the following constraint in mind, that a Lambda function can use up to 5 layers. And then each layer has a maximum size limit of 50 MB, like compressed. And the total size of the uncompressed function code and layer combined cannot exceed 250 MB. Another important point to note is that layers are immutable. So that means any update to a layer creates a new version, and functions must explicitly reference the updated version to incorporate the changes. Let's look at like few of the use cases of Lambda layers. So Lambda layers can be used in various scenarios. So some of the scenarios are shared library. Shared library can be packaged in layers. So an example will be that if you are using a Python as a programming language, Pandas is a very popular library, and you can include that library for use in a layer, and then it can be used by whatever other functions you have there as Lambda function. Custom function, that's another use case. So you can have a custom function, and that can be packaged in the layer and reused across multiple Lambda function. This is actually the scenario that we will be doing in the hands-on, right? And then there is a common configuration that you can be, include in a layer. Logging utility, you may have a class, you can that a logging utility that can be included in a layer, and then it can be used by multiple Lambda functions. So to use the layer, what we need to do is we have a function, so we need to import the required module and layer functionality. So I have this is my function which is going to use the layer. I'm importing the JSON, so that's one step, and then I'm also importing the hello greeting function from the layer, right? So this is my layer, hello world layer that I have created, and I'm importing hello greeting function. And then in the handler, I am getting the I'm actually, let me see. So I'm passing the name in this function, the hello greeting, and then based on the message that I'm getting is that I'm returning that message in the JSON format. So that's really like the three steps that I'm doing. Now that we have both the Lambda layer and the Lambda function code, let's proceed to build the layer and reference it in the Lambda function. To develop and validate the layer and Lambda function locally, I will use AWS SAM. AWS SAM is especially useful for testing and debugging Lambda functions before deploying them to the cloud. I have previously posted several videos on AWS SAM and Lambda covering these steps in detail. If you are new to AWS SAM and Lambda, I recommend watching those videos for a better understanding. Let's review the template YAML for the AWS SAM. If you look at it here in this file in the YAML, I have two key resources defined. The first resource here is hello layer, and this is the layer that I'm going to create using this SAM template. It has the layer name, the description, content URI. This is where the code related to this layer is. And then we are using a runtime of Python. And then I have the retention policy as well as the build method using Python 3.11 runtime. The second resource here is the Lambda function, and this is a very simple hello greeting Lambda function using the same runtime of 3.11. It has a timeout of 5 seconds. And then the most important thing here is that if you see the layer property, I'm actually referencing the same layer here that I am building through this AWS SAM. So this SAM template file has both the resources, the layer itself, and then the function that is referencing the layer. Now, since I'm using AWS SAM for this function, let's begin by building the function, and the command to build the function using AWS SAM is SAM build. So once I run the SAM build, and if my function get built correctly, then I should see a message that build has succeeded. Once build is succeeded, I have two options. I can test it locally, or I can deploy it, or I can first test it and then deploy, right? So in this scenario, since my build is successful, I'm going to use the command SAM local invoke, giving the function name, which is hello greeting in this example. And when I invoke this, I will expect to see an output similar to where I'm getting a status code of 200 and the body is saying hello Girish, and it's returning hello Girish because my parameter is set to Girish in the function. So hope that makes sense. And now since I have validated, the next logical step for me is that I can deploy this function to the AWS Cloud, and the command is SAM deploy, and this is really the workflow. So this is a very concise workflow demonstrating that how to create, validate, and deploy the Lambda function using AWS SAM. And as you can see that by leveraging AWS SAM, you can streamline the development process and ensure your functions are tested before deployment. Once you have completed the setup, ensure you delete the Lambda function to avoid unnecessary resource usage. Additionally, delete the Lambda layer. If you created any new role during the process, remember to delete those as well. Since these resources were built and deployed using AWS SAM, these can be deleted using AWS SAM command. Command to delete the resources is SAM delete. You can also delete the resources via AWS console. In this workshop, I demonstrated how to create a Lambda layer and reference it in a Lambda function using AWS SAM. In my previous videos, I showed how to create a layer using the AWS Management Console and then reference it in a Lambda function. However, in this workshop, the entire process from creating the layer to referencing it in the Lambda function and then building and validating was accomplished using AWS SAM. I hope you found this tutorial both helpful and informative. I am constantly working on new content covering various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.